Okay, picking up where we left off. Last time we had our listeners set up an Empire. We printed out a stager, and we put the stager in a web directory that's accessible. And I was working on getting that on the Windows host so that we can get an agent. So let me go over here and I think I have some agents running, so let me just shut those guys off. I was just testing, make sure this is all gonna work without getting too distracting. Okay, so we'll go back to the main window. We got 2 listeners running, and I don't have MSF console up just yet. We'll get to that in a second, but just to remind you, we do have 2 listeners running, and let's go ahead and get the agent up and running. So I'll get on that Windows host, double check the internet works. Yep. And then we're going to access that launcher.bat. Go ahead and run that. You'll see the little pop-up. And then in the background, you'll see our agent connecting. Again, that launcher.bat was what we created with the use stager command. Okay, so we have the agent now. We can go interactive with that agent. We can rename it. And I remind you, use that question mark help menu. You can get some info about it. So nothing too interesting in there. One of the things that is useful is having that internal IP so that you know that roughly what the network IP range is for your targets. So our next step is that we're going to inject a Meterpreter listener or an Meterpreter agent, and I'm going to do this the wrong way first and show you what happens when you do it the wrong way, so that you don't spend too much time with a Meterpreter session that isn't really a full session. So what we need to do is get our MSF console running and get a handler running. So on this guy, we need to inject shellcode Meterpreter, and then we do need to specify a process ID. So when you look at the options here, it's going to ask for a process ID. And by default, I think it just uses the last one I was using. But let's go back and figure out what the process ID is that we need. Well, actually, we'll do a random one first and show you what happens. So we'll run a I'm going to reduce the latency of this to make it a little bit faster. Okay. So let's get a process listing. One thing you'll notice is the architecture column here. Meterpreter really only works with the the correct architecture, I should say Empire really only works with the correct architecture, which is a 32-bit architecture. And I've also noticed, one of the things that you'll probably notice is there aren't really that many processes here. So one thing I always curious about is whether or not the user on the system is an admin. And off the top of my head, I don't remember if there's a way to tell if it can be an admin without just attempting it. But if you do run the show info, you'll see this high integrity 0, which means we're not in an admin context. And you can also see that because there's no asterisk in the agent listing. So we can interact on this guy and then attempt a bypass UAC, which will check to see if, well, essentially it will try and get a privilege escalation, and if it works, it means that the user is a local admin, and we'll get another agent back, and you'll see the asterisk there, and then when you interact, you'll see the high integrity is 1. When you get a process listing on this guy, you'll also see quite a few more processes. So quite a bit more than we saw last time. So if you do grab a random x86 process, let's try 1632, inject shellcode, Meterpreter, 1632. When you run that, it automatically puts this in there for you. All these options look good. I've already had this configured, but we still need to set up this handler to catch the callback. So over here, we're going to run a use exploit interpreter. Maybe Windows first. Windows interpreter. Pretty sure that's what it is. Exploit multi-handler, mixing things up. Use exploit multi-handler, and then we need to set the payload to what's going on here? Windows Meterpreter, yeah, I don't know what's going on. And show options. And our lhost is going to be our local listener host name. This can also be the IP address of our C2 infrastructure. So set the lhost, and Meterpreter is pretty nice in that it'll automatically fill that out for you. And if you just hit tab a few times, it'll show you your options. Pick your public IP, show options again, make sure everything's filled out properly. Everything looks good there. And then we're going to run it, but we're also going to add this -j to put it in the background. It's going to say no session is created. If we run a jobs, you should see this running. One thing you'll notice is that I forgot to set the port. So if we look at the port here, we look at the port here, they don't match. So let's just go ahead and kill this job and check out the options again and set this properly. So that's why it's pretty useful to just confirm that you're doing everything right. Run -j and run another jobs, and that looks a lot better. Okay, so that's really all there is to getting that set up. We can go over here and type execute. And you'll see on the right, we have a Meterpreter session that opens up. So if we type sessions, the first indication of problem is that there's nothing filled in this information box. And if we try and go interactive on that session, well, you gotta type sessions, not session. And we get a sysinfo. We can't really do much with it. Can't even run a sysinfo. This is not it's not a full Meterpreter session. And I'll show you what the difference is when we get another one. But this is even the correct x86 architecture, but it did not have the right permissions. So sometimes you do land on a box. Whoops. Sometimes you do land on a box, and there are unfortunately no good processes for you to take advantage of. It ideally is running under the current user context and the correct architecture. Luckily, Empire does have help for us. You can hit that question mark and then look for this spawn. And let's go ahead and run that guy. Whoops. And the important part here is this syswow64. What this does is it will give you the opportunity to spawn a 32-bit process. Unfortunately, it still will be a PowerShell process, which is pretty obvious to blue teamers. But for the purposes of this exercise, hiding your activity is kind of outside the scope of what we're talking about. So let's go ahead and set this syswow to true. And everything else looks good there, so let's go ahead and execute that. So now what you'll see is that we have a new agent with this PID of 2624. If we run a PS, well, interact. We can even interact with the old one that we originally used. It doesn't really matter. 2624 is what we're looking for. 2624, you'll see that is an x86 process, and it is running under our user account. So if we inject this shell code one more time, interpreter 2624, and then execute, just going to confirm we still have our handler running. And we get another session, and if we look at this one, the first thing we'll notice that's different is that we get some information to accompany this session. And if we -I, go interactive on this session, oh, once again I spelled it wrong. And we type a sysinfo. We actually get information now. If you run that question mark, all of a sudden you get far more commands than we saw last time, which means it's properly loaded all the functionalities. Without having a full functionality, we don't get the ability to go interactive with their file system. We can't really get networking, definitely can't dump hashes or anything like that. So you really do need a full session. So just want to show you again what that looks like. There's the difference. I'm going to kill that first one, Doesn't really matter that we do that, but just keep things tidy. Okay, so just have that one session. And then really the goal of this is, now that we have a foothold on this system and we have a Meterpreter session up and running, we want to be able to send traffic into this network and do a little bit of recon nearby. So we have a session. Let's make sure we add our route add, and then it is useful to have this IP address down here, because that will give you an idea of what the IP address of the local subnet is. Add the mask, 24-bit. And then the last argument you need to add is the session ID. And if you run a route command, you'll see if it's added properly. You're going to route traffic for this subnet with this netmask through session 2. So what we're doing is anything that Meterpreter or Metasploit wants to interact with that has an IP address in this range, it's going to get routed through session 2. So we can couple this routing, this Metasploit framework routing, with another functionality, which is a SOCKS proxy, which will accept connections from any application that's proxy aware and allow us to route it through this Meterpreter session. So we're going to use Fox SOC, I think it's 4A, might be SOCKS 4A. SOCKS server 4A, or auxiliary server SOCKS 4A. Let's see, run an info. The only real configuration we need is the listening port. I'm setting mine to the default, and you can set yours to whatever you'd like, but mine is going to be set at 1080. And then once again, put this in the background. Now, it's not obvious what that has done, but we'll see here in a minute exactly why that's so beneficial. So I'm going to add another tab, and then I'm going to show you something called proxy chains, which is a way of sending command line applications through a proxy, all from Bash. And then we'll discuss how to do this from a web server. So the first thing you're going to want to do is make sure you have proxy chains installed. I already have it installed, so I don't need to run that again. When it is installed, the configuration file will be under etc proxy chains. And really the only thing you need to make sure is set properly is this value here, which tells it to listen on your local loopback adapter on this port. Actually, I don't even need to do that. So once you do have all that working, you can use applications like Nmap on the command line through proxy chains. So proxy chains Nmap, ignore whether or not it gets a ICMP traffic. One idiosyncrasy I found with the Linux networking stack is that you need a full TCP connect. That on a Mac you can use a SYN scan, but you need a full TCP connect, three-way handshake on Linux. Just a bizarre idiosyncrasy, not quite sure exactly why. So let's just confirm this is working and send a request to a Windows host where we expect to be open. And we can even confirm this by, I think it was 1. And just to remind you, we do have the opportunity to run things like a netstat on this. There's the netstat right there. So we can netstat on this host. And the benefit here is that you're going to see listening ports. And this gives us the ability to see what ports are going to be open. So let's just confirm with 3389 for instance. And then 172.168.115. This is that host, which I've already forgotten the IP of. Interestingly, you can see our connections to our C2. Oh, it's 73, okay. All right, everything looks good there. Now what this is going to do is it's going to pass this nmap command through to proxy chains. The proxy chain is going to leverage the config file to know to look on port 1080 for a SOC server, which, as you might recall, is running in Metasploit. So let's go ahead and run that. And well, that ran really quickly. This is the important thing you want to make sure you see, is that this proxy chain is set up between this local listener and this remote host. And it's saying OK, as in it's open, we confirm it's open. So this is checking from our remote C2 to our remote, our foreign target. Now this is great, but it really only works for things you can send on the command line. So let's now expand this into things that need, say, a graphical user interface, like doing recon on websites, or perhaps you might even want to log in interactively on this host. So for that, let's go back and we'll look at our SSH conf file, and one of the things that I've added here, which is because I know I'll need this when operating on these hosts, but it's a local forward. So what this is doing, and you can pass this on the command line by doing something like ssh-l 1080. It's basically the same format, but on the command line. But what this is saying is set up a local listener on port 1080 and route that to our remote host listening on the loopback adapter on port 1080. That might be a little bit complex, but it is basically mirroring the remote SOCKS proxy on our local host. Therefore, we are local. This is my Kali box. This is running on my VMware Fusion or VirtualBox or whatever you want to use locally on my system. It's not in any way connected to the remote infrastructure except for that SSH session, which is tunneling that proxy service. So if we look at our local system, we can see we can see that this port 1080 is being provided by our SSH command. What does that allow us to do? Well, we can run proxy chains locally as well. So once again, you need to have proxy chains installed. And once again, you need to make sure the proxy chains is set up on the right port, which it's not. So we're going to fix that. And now let's try the exact same thing from our local host. Proxy chains nmap -pn -st. I think that's right. 73. Nope. That looks good. Oh, port. And you can see it took a little bit longer because we're hopping through the SSH tunnel as well, but it is open. That's a really good sign. So now we can use proxy chains for something like our desktop. And 73, specify the user. We know that from previously. We do need the password, so let's just go back here and see if we can run a Mimikatz on it. I think it was 2. I think it's oh, I misspelled. That's not going to work. And that's not a good sign, having a timeout, but let's hope that the session didn't die. It's possible that that session has died. No worries, we can run this again, although our handler is no longer up and running. so it's not going to work until we oops. Looks good. Whoops. No. So you'll see we don't have all that information. So clearly we are running on the wrong PID again. Let's just go double check our process list. So something you'll notice is that this agent did actually die since we injected Meterpreter into this process. Once this process died, we probably lost everything. So let's just go ahead and kill that guy. And we'll interact on this guy. We'll spawn another one, and whoops. Set that to true. Execute. So we now have the new PID that we need to inject 3236. It's helpful to get those passwords immediately, just in case something like this does happen. And this is something that also does happen. You can run a jobs, see that you definitely aren't running on anything on 8000, but when you try and start up the handler, it says it's already running. So in those instances, just the only thing that I know to do is close MSF console, reopen it. It's a little bit frustrating for sure, but don't really know how to get around it. Payload. That all looks good. Oh. Try this again. Ah, right. We may need to migrate. So this is getting a little bit more complicated. Mimikatz needs a 64-bit process. So let's migrate into 584. This should also give us a more stable session. If it works. Yay. Okay. Whoops. Okay, so we got Mimikatz to run. Let's hope that we got a password. Sure enough, here's our clear text password. So we can go all the way back over to here and connect to proxy chains. Now we're forgetting to background this route add, and this is session 1, and then we want to have that socks back up. Okay, so we got our socks proxy up again, and we should be able to get this to work. Enter that password, and we have a full connection to that host that we were previously we previously had access to, but it was through local. I was pretending to be the user clicking on something, and now we are definitely the attacker, and we're using our Kali box to get into this. As you can see, this is in my Kali box. And the other thing you'll notice is that we are routing this again with proxy chains. So that's a pretty neat little exercise. Another one I would like to show you is how we use this with a web browser. So we were used to running proxy chains with Nmap. So let's just go ahead and see if there are any other hosts on this network. We'll do 74 to 78. Let's see if there's anything else. And we're just going to scan one port because going through proxy chains, it's a little bit slow. And so what we're doing right now is we're looking for port 445, which would be a pretty good indication that there are other Windows hosts on the network. So already we can see one .78. I'm going to call that good enough, and let's just focus on .78, and let's look to see if there are any other services being offered. So I happen to know that it has something in the 8,000 range. Unfortunately, this is going to be pretty slow. But as you can see, we already see something on 8080. So let's go ahead and check 8080 here in a little bit. So while this is running, let me show you how to get this configured so that we can access this with a web browser. And you might be saying, well, why are you going for a web browser? I'll just open a new tab and show you. So if we run a proxy chains nmap -p8080-sv. Oh, did the wrong one. Okay, 8080. As you can see, that there aren't many ports open, and it does take quite a long time. So you want to be quite targeted when running this kind of an attack through proxy chains. All right, so coming back over here, the reason that I'm wanting to head for a web browser is because my expectation is that this is a web server. And this might actually be a vulnerable web server. And there might be some other vulnerable services on this host. So in order to do that, just like when we configured burp for a proxy, we are going to configure Firefox. Just instead of using burp as the proxy, we're going to use proxy chains. Well, actually, not proxy chains. We're going to use the SOCKS proxy we set up, and the port forward with SSH. So now we can type 172.168.1.5.78.80.80. And this is this Glassfish server running on a host that's adjacent to our target host. And I'd love to have a little diagram to show you exactly how we're doing this, but let's see if we can just notepad it. So we have our target host, and then which is .73, and adjacent to that we have so on this one, on this one we have our Empire agent. .78, and then we are using this to connect to our C2, and then our C2 it's really hard to draw this in text. I think I might just draw it out on a slide and insert it in the video. Yeah, let's do that. I'll figure out a way to draw that and insert it into the video. But this is really what I wanted to show you. And then let's just go back and see if we see any other open ports. Nothing yet. I think it was Yeah, 8484. Let's try this one. This is the one I was trying to show you in class, I think. Nope. This is Jenkins. The one you know and love. Probably won't do that one. I might just have to look to see what port it was. Since that nmap runs so slowly. Okay. I think this is the one I wanted to show you. It is open. Let's run a -sv on it. All right. Apache, HTTP. Clearly see that just loading it in the web browser was way faster. Desktop Central 9, so let's just search exploit for desktop. Desktop Central 9. Oh, look. It's got plenty of stuff. And it looks like there's one baked into Metasploit as well. So let's just go back to our remote host because it'll be a little faster from that, and search for Desktop Central. Looks like a bunch of stuff. Here's one specifically calling out 9. So let's use that one, wherever that was. This guy. So let's use exploit Windows HTTP manage engine. So we're going to set the R host to 172.168.1.15.78. Our port is 8020. We saw that right there. It's the port it's running on. And don't need SSL. It looks fine. We're going to want to set the payload to yeah, let's go ahead and see them all. So you can set it to another interpreter shell. So let's go ahead and do that. Windows, interpreter, reverse, Sure, we'll do that. Now the one thing you'll want to be absolutely sure of is that whatever this is going to fire up, you have listening on your firewall. So if you have it set for L port 4444, you need that open on your firewall. So let's set the L port to 9000. I think I have that open. Let me just check my firewall. I do have 9000 open. Okay, so that all looks good, except I need to set the L host. And execute. Now, just to remind you, this is getting run through that route. So let's go ahead and run this. So it sets up our reverse TCP handler and uploads the stager, and as you can see, we now have a shell on this Windows 2008 R2 box. So from here we can load Kiwi and I suspect we have the same problem loading x86 Kiwi on an x64 architecture. So once again, we'll have to migrate. I like migrating to LSASS 456. Oh, we don't have sufficient privileges to migrate there. We're an unprivileged user. So let's just migrate to another 64-bit process. Apache looks good. 3408. You generally don't want to migrate to a process that the user might be closing, because then you'll lose your session. Not really sure exactly what this error is, so I'm guessing it has to do with permissions. We could attempt, I don't think we have privileges due to this. Yeah. So in this particular instance, we're going to have to find a privesc because we don't have privileges as this user. There are some users logged on. There are ways of privesking, but in this particular instance, we don't have the privileges to do it. So, but that's really what I wanted to show you. We were able to move from this original box, this local workstation, onto one of the servers without any sort of external access. This is completely behind a firewall, and yet we were able to move laterally within the network. And that's really the crux of it. That's how we want to prove and demonstrate pivoting. So from there, basically we're just going to want to practice our skills and our techniques for all the normal stuff while having a thorough understanding of all the networking involved with this. And like I said, I'll try and put a diagram together that kind of, as clearly as I can, show exactly all the components involved with how we get from our local host at my apartment behind my firewall all the way to this remote cloud infrastructure running our C2, and then back into yet another network behind yet another firewall, and make that all work and look pretty easy. At least it didn't look too difficult. Anyway, let me know if you have any questions, and I'll try and clear things up, but make sure you understand the networking aspect and practice this stuff.